If you've watched any of my build videos, chances are you've seen me use a version of a shop-made horizontal slot mortiser. The Mark I you see here was pretty crude, but it did get the job done. The Mark II was a big upgrade, and it had some new features, but still had a couple things that I've wanted to improve for a while now. So today, that's what I'm going to do. I'm going to build the Mark III that's an improvement on the Mark II in almost every way, and I'll even have plans for this one available on my website. So let's get into this build. This mortiser is primarily being built from a sheet of 3/4 plywood, and the first step is to break that down. I worked out a cut diagram that let me break down the sheets into some manageable chunks that I can then take over to the table saw to cut everything to its final dimension. There's a fair amount of parts here, so I make sure to label everything so that I can keep them all organized during the build. So I'm going to start by laying out my linear bearings on the lower table. So what you need to install these is a little bit different than what you'd think. These linear bearings are threaded, and you have to really get the positioning of those just perfect and spot on. And you could, I'm sure, drill in from the opposite side of this and get them lined up in a way, make them loose or something. But what I've found is that these linear bearings are perfect for a number 8 screw. And what I found is that the 1.5" pocket screws are absolutely perfect for this. Now, I don't use pocket screws on a lot of things, but for this, I'm going to misuse them, I guess, a little bit, but they work perfectly. So I'm going to start with 1 screw in each bearing. Recheck my square. I'm going to run 1 into the opposite bearing. Now at this point, the square is not going to do anything. Having the linear rod in here will keep it square, so I can go ahead and install my other 3 screws in each one. Now for the other side, I'm going to mark my depth so that it's just as far in front to back, but I'm not going to worry about my position left to right just yet. The plate for the router is 12 inches across and 9 inches deep. Makes a perfect spacer for these bearings. And by doing it this way, rather than marking square again, I can just make sure that they are completely parallel to each other. So I'm just going to use that as a spacer. Next thing is to install the feet onto the linear rods. Now there is an Allen key to tighten these down, so I'm making sure that those are pointed out, but I'm not tightening it just yet. Just like before, I'm going to mark my distance for 1 set of bearings. Now this time, And instead of using the router plate as a spacer, I'm going to use 2 of the, well, they're spacers, the side spacers that will be on the next layer up here. And I'm going to use them, and I've marked my distance from the outside. So all I have to do is come and align them. Now, these linear rods, and more particularly the feet, are a little bit harder to install because on this bottom one, I can slide the table out of the way. That is not the case with this middle table, okay? So what I'm gonna do is I'm gonna take the linear rod and feet off the rear set, and I'm going to pre-assemble them and install the feet with the rod in place on this bottom table. Now I've marked up my distance from my front edge, and I've got this centered left to right. And just like on the other ones, I'm going to pre-drill and screw. So there's a couple ways to do this next step, and I'm going to do it with some double-sided tape. Okay, so now next, I'm going to take and reinstall these, again, leaving them loose. Remove the double-sided tape and stick them to the layer below it. I'll be installing a piano hinge on the front edge of the work platform to give the Mortiser a tilt feature. I measure the thickness of the piano hinge and set the height of a dado stack to half that thickness, not the thickness of one of the leaves. I'll run the upper table and one of the front spacers through the dado stack twice to get the full 1.5 inch width of the piano hinge. With that sorted out, I can start building up the spacers and get the upper table installed. I glue and brad nail on 2 layers of spacers onto the middle table, and the front spacer I just dadoed goes in the very top layer. The tilt hardware has to tuck inside that pocket left by those 2 layers of spacers I just installed, and since the 3/4 inch plywood isn't actually 3/4 of an inch, I need to cut the hardware to the actual height of 2 layers of plywood, which is about 1 3/8 inches. I cut several strips, and then I need 9 pieces that are 3 inches wide. Now 3 of those pieces are going to be used to mount the lead screw, and 2 of those have to be drilled out for a 5/8 bushing that will support the lead screw. The third one is just going to be a spacer and doesn't need anything drilled out of it. Now at this point I had the design for the tilt mechanism about 90% worked out, but I needed to do some testing. With the first version you're seeing here, I mortised out a cross member for the lead screw nut and epoxied that into place. I added one of those blocks to either side of it, and I got that and the lead screw installed into the table so that I could do some quick testing. So far the cross member stayed even and moved pretty well, which was good enough to move on and get the blocks installed on the upper table. Next I did a quick and dirty temporary installation of the support arms and played around with raising and lowering the table. I wasn't happy at all with some of the flexing I saw in the cross member, and I didn't like how the support arms were supported on the top, so I took it all apart and remade the cross member. This time I made it 3 inches shorter and doubled it up, fully encapsulating that lead screw nut. This moved the support arms in closer to the center, and then I added a second set of support blocks to the top. All of that together did the trick and made everything both smooth and sturdy, and I was happy with it now. Okay, if I'm being honest here, I probably did this about 5 dozen times once I was happy with it. Raise it, lower it, raise it again. After all the work I put into it, it was just pretty satisfying. Alright, time to move on to the platform. Just like with the last 2 versions of this, I'm going to be using match fit dovetail clamps to hold everything down. It really turned out to be the perfect work holding solution, but that means I need to cut a bunch of dovetail slots in the platform. And before I do that, I like to remove a bunch of the waste with a 1/4 inch dado stack set a 1/4 inch high, or deep, or whatever. Then I can set up the dovetail bit at the router table and cut 3/8 of an inch deep. I have the dovetail grooves in both directions, and the pattern that I had in the last version actually worked out really well, so I just repeated that here. Once the grooves were all cut, I could laminate everything together. I'm laminating 3 layers here: the upper table, a 1/4 inch plywood spacer, and the top platform. That 1/4 inch plywood spacer both helps keep everything from warping, but also provides some necessary clearance over that front hand wheel. Once all 3 layers are together, I drive in some screws from the bottom and then let that glue cure overnight. This mortiser does everything based on a center line, and that means that center line is incredibly important. And to get a real crisp and accurate center line, I use a knife to mark a fairly deep line all the way down the center. Then I come back and go over that line with a pencil and erase anything on the top surface. This leaves just the pencil line that's in the actual knife cut, and then when I apply finish later, that perfectly crisp line will be permanent. front edge of the table gets stops made from 1/4-inch plywood scraps, and there are two things to note here. First, I'm not gluing these in place. They can get damaged over time and I want to be able to replace them. Second, I'm not installing them covering the dovetail slots or the center section. The dovetail slots will collect sawdust if you block them, and you need clearance for the router bit in the middle. Okay, this video is getting to be a little bit longer than my normal ones, but stick with me here. We're just starting to get somewhere. The tilt platform is all sorted, and now I just need to get the router lift taken care of. The structure for this is pretty simple. It just consists of a couple of reinforced uprights made from strips of plywood and a couple of supports in the back. Now I did make a small error here that bit me in the ass a little bit later. When I clamped the rear supports on this, it came out of square with the front by just a fraction of an inch. You can see the small gap at the edge, but luckily I was able to account for it later. The next piece is a mount for a safety switch. Now I need to drill a hole to pass the cords through, and then it gets added to the right upright. I probably should have done this before gluing on the rear support, but that would have just made the glue up a little easier, and it didn't actually cause any problems. Gluing the uprights in place was a little tricky. I had to rely on marking everything out and placing the uprights carefully on those marks while I drilled in some screws from the underside, but it did go off without a hitch. The top gets drilled out for a 5/8 bushing and then glued and brad nailed in place. Next up is the router plate. I need a set of good center lines to mark out for the router mounting. I can use those center lines to line up the base plate off the router to mark out for the mounting holes. The center gets drilled out with a 2.5-inch hole saw. Then the mounting holes get a counterbore and then get the through holes drilled. The linear bearings get installed on the router plate just like on the tables, but this time I need to reference the outside edge on both sides and I can't use a spacer. Keeping the linear rods in place while I mount them kept everything square and parallel, and I didn't have any issues. Mounting them to the uprights, however, is when I realized that the left side was a little bit out of square. I was able to correct for that by using some washers as spacers behind one of the mounts, and that squared everything up. The lift mechanism is built a lot like the tilt mechanism. I need a couple of blocks drilled for 5/8 bushings and a couple mortise to accept the lead screw nut. Now I'm getting ready to actually attach this to the lift itself. So one of the things I need to do is to make sure that everything is in line and square, and so I've done that. I've put the lead screw in and I've run it up and down and make sure everything moves smoothly with these two blocks clamped on. And I'm square in both directions, which explains why this is running up and down so easily. So now I need to get all three of these blocks glued in place. So the first thing I'll do is this block down here. That'll be the easiest. So now I'm going to lower this down and get it resting on something. I actually do have these stops on here, but I don't think they're going to be needed when this is all said and done, so I'm probably not going to have them in the plans. So basically I want the weight supported. What that's going to allow me to do is just pull that back to get some glue on the front of this. The lead screw gets reinstalled with a collet locking it in place on the top and the bottom. Then the router base can get mounted and the router inserted. Okay, we're getting close to done now, and there's just a couple more pieces to make. First is a couple of dovetail tracks that will be used to set the stops. Rather than taking the time to set up a dado stack this time, I just ran the piece through twice, flipping it in between passes. Then I routed the dovetail slot just like before, and this one track will get cut down into two. One for the lateral stops and one for the depth stop. Those get glued into place and I can make 3 stops out of walnut for no other reason than because I like it. They absolutely could have been made from plywood. The very last piece to make is a fence. This is better if it's a little bit thinner, so I mill a piece of scrap down to 3/8 of an inch thick and then cut it to size. The fence needs 2 slots cut into it to allow it to be adjusted to any angle, and since I have this fancy new slot mortiser now, I double stick taped it to a piece of scrap and set the mortiser up to cut a 5-inch slot. Alright, let's see what this thing can do. I appreciate you watching, and I hope this is useful to you, and I do have plans available for sale on my website if you want to build this same thing.